how do we use Desmos to evaluate a definite integral? You might be saying, can't I just use the fundamental theorem of calculus? You would be able to use the fundamental theorem of calculus if you're able to find an antiderivative of the integrand. But perhaps you have an in, perhaps you have a definite integral that has an integrand that you're not able to find an antiderivative for. In that case, you'd have to resort to an approximation technique such as Simpson's rule, the trapezoidal rule, or perhaps a Riemann sum, or you can use a graphing calculator or Desmos to have it numerically approximate the definite integral for you. And if you're using a graphing calculator or Desmos, you'll get something that's accurate enough for whatever you want to use the answer for. But let's go ahead and see how I got this. So we have the definite integral of sine of x divided by x with respect to x from x is equal to 0.3 to x is equal to 4. So here's how you do it. Let me repeat what I did so you can see how to do it. So I go to a new cell, and what you need to do is go to the keypad, and after you go to the keypad, you'll go to functions, and it's under miscellaneous, and it's at the very bottom on the left side. So I need to go back to cell 2 and go to functions, miscellaneous, this one here. So now you can see that the cursor is in the position of the lower limit of integration. I'll enter 0.3, use the up arrow. I will enter 4 for the upper limit of integration. Use the right arrow. I want to enter sine x, so I can go to functions, trig, then I have sine x, close parentheses, division bar, and type in x. Right arrow, type in dx. As soon as you do that, there's the value of the definite integral. So Desmos evaluated the definite integral for us.